Hey guys, John McGinley here with REDspace. We are just going to wait another minute or two to let some more people file in, but excited to have you here on a Wednesday afternoon, morning, evening, depending where it is you're coming in from. This is the first in a series of webinars that we are going to do from REDspace. We're really excited to be kicking off with my friend and principal developer here at REDspace, Jamie Stackhouse. We'll let you talk. We'll let him tell you a little bit about himself. But before we get started, I wanted to take care of a little bit of housekeeping right off the top. So, question I get asked all the time is, will this recording be available? Short answer, yes. About a day or two at the most after we will make we'll clean it up a little bit and make it available to everyone who is signed up. So don't have to worry about that. The next question I get asked a lot is Q&A. So if you look in the tray at the bottom of your window here, there is a little Q&A. You can submit your questions there. We'll gather all the questions at the end. Oftentimes we'll have duplicates, so I will sort of make my way through those, edit those. We'll try to get to all of the questions, let Jamie answer them live, but if we don't for some reason, we will get back to you. So feel free to put some stuff in the Q&A tray. We will try to get it addressed in a timely manner. Other little housekeeping issues, and this is intended for informational purposes. The ideal audience for this crowd would be, let's say, developers, content creators, anyone who might be in or soon to be in a leadership position where they may be buying technology or negotiating with vendors. All of this information, while it is going to be a little bit on the technical side, Jamie has a ton of experience. REDspace has done this type of work for a bunch of organizations, so we will obviously have an opinion, but it is not legal advice. Our lawyers tell us to tell you, seek legal advice when it comes to anything around DRM or anything in that vein. So this is not legal advice. Jamie's opinion based on years of experience. So with all that being said, I will kick over to Jamie, who's going to take us through about a 35, 40-minute presentation, and we'll have some time for Q&A at the end. And without further ado, Jamie, the floor is yours, sir.
Thank you very much. So like John said, my name is Jamie Stackhouse. I'm a principal developer here at REDspace, and my career essentially started when it was Flash. Experience with Flash LS, so doing HLS delivery with the Flash player, moving into HTML5. At the time, it was Comcast, the platform, and we moved into Bright Cove and then all of the different providers, Encoder. And effectively, I've worked with many of the providers, worked with all of the different DRM vendors that are out there. And what I mainly found was that a lot of this information was kind of left to be discovered and wasn't documented, was kind of intentionally vague. And so what I'm hoping to do is kind of give you the base fundamentals to kind of know the terminology. So with that, I'm going to get started here. We'll talk through some key terminology and concepts that are crucial to understanding the work that's done for both securing media distribution as well as the playback side of DRM. So before I dive into the presentation that focuses on the terminology, let's do a high flyover. On the right-hand side here, you can see a basic systems diagram, which showcases both your inputs as well as the outputs, going from encoding your media, packaging it with a DRM provider, making it available for playback, and finally, the actual playback APIs themselves. The data flow here of your media is oriented to be north to south. So to do that at a high level, what you'll see nowadays is the CPIX specification, along with a DRM backend service to help you generate the encryption keys that are used to encrypt your media. And along with that, you'll then create what's called playback licenses. On the right here in the diagram, we've got a packager. The packager utilizes some internal data to create what's called a unique crypto period. That represents a slice of time. that will be encrypted with that specific key. And it's represented by a key ID. It communicates that information using a CPIX protocol to DRM backend services who fill out a document or the CPIX document. And then the packager can use that information to protect the media. At the same time, the backend will store the information and is capable of returning playback licenses to users so they then have the ability to play that media. So here's an example of a small piece of the CPIX document. There's a few steps to parsing this, which are defined as part of the CPIX specification to enable secure delivery. There's a document key that will be used to encrypt the entire document. As well, there's a signature process that involves your public key, so essentially identifies who you are or who your packager is, and you'll communicate with the CPIX server who is creating this document for you to validate the payload. So you know that you're getting this from the DRM provider you're expecting to communicate with, and you're creating it, and they know that it's coming from you, so they'll return key material. One that isn't part of the spec, but is incredibly important, like as an implementation detail, is the cipher value that you'll see in the middle there. It's actually both what's called the initialization vector and the actual content key. So the actual like 16 bytes that are used to encrypt the media. And that's kind of like a standard that's done across the industry, is that they'll package both of those into one value. It's not specifically specified in any spec of CPIX. That's just become the industry best practice. And I believe is included in some of the appendixes now as well. At the bottom, we also have the HLS signaling data, which will show up again at the end of the presentation when I show that specific implementation for HLS. So it's important to kind of consider where you are in the digital rights management or the DRM stack. There's kind of two main areas that you could focus on. You've got the content preparation. This is where your content's created, encoded by an encoder, packaged with the packager, and then in that process is protected, encrypted. And then you have on the other side the content playback. This is where the content's actually consumed by your users. Overall, DRM aims to protect the transfer from the preparation phase to the playback phase. So let's discuss the encryption. Encryption is really the backbone of what makes DRM work. It's broken down into three things: algorithms, bit sizes, and modes. The algorithm widely in use today, AES, is used to secure digital content. There's different types of AES called modes, and encryption modes are really kind of considered the implementation detail for how it's going to do the encryption. In the AES CTR mode or AES counter mode, encryption happens in chunks, and each chunk can be processed in parallel. That's great for speed, right? You can decrypt in parallel across all your content. In AES CBC or cipher blockchain, encryption has to happen serially, one after another, using data from the prior block as input to the next block in the encryption algorithm. This makes it easier to be more secure, as you don't have to generate what's called the counter in the other encryption mode. It's effectively getting mixed along with the video data itself to generate that cryptographically secure random data. These encryption modes are used within the protection systems, but are independent of them. This means that I could use CBC or CTR with any of the protection systems that are available. There's many different protection system vendors, but the main ones across the major platforms that we work with is Widevine, PlayReady, and Fairplay. To ensure compatibility across all those different vendors, there was a specification made called common encryption. And by following common encryption, you can support all these different vendors who offer these protection systems using those different encryption schemes. And yeah, schemes is not me misusing the modes term from earlier. It's another term entirely. So, encryption schemes, they're really kind of bundling those three things together. They're tied to the specific mode and how you encrypt the media. A scheme combines the mode, which is essentially whether it will do full or subsample encryption, where full encryption, you'll encrypt the entire sample, but none of the metadata, whereas subsample only encrypts a portion of the media and follows a pattern of encryption. This diagram shows a very popular pattern called the 1-9 pattern, where only 10% of the actual media is encrypted. Whereas here is the full sample encryption mode, where the actual data is combined with the encryption, the entire thing to produce the now encrypted data. So if we combined encryption schemes along with the protection systems and then the common encryption specification, that kind of leads you to a fairly complete picture of the various terms that are shared across preparation and playback. Encryption modes like the counter and cipher blockchain is key to grasping the technical detail of the foundation of DRM and how it can create security and accessibility for your digital content. All these aspects come together, enabling flexibility across various platforms while maintaining security. So now that we have common terminology to describe it, let's take a quick look at the process for content preparation. To start, let's look at specifically the protocols that are involved. We've already talked about this one briefly, but so CPICs first. There's a few important terminology things inside of CPICs itself. So you have the XML canonicalization and then digital signatures, and they kind of go hand in hand. Canonicalization is really converting that XML, which is a data format, into a standard kind of like way of listing it out. And that's so that you can consistently sign it and validate the integrity. Like I mentioned before, where you have a document key and you want to make sure that this came from the other party. If you've never made a list of something and sent it to someone else, and then they're like, hey, why did you not put this in alphabetical order? That's effectively what canonicalization is doing. It's giving you that list of things of how you should sort it, and you agree on that beforehand. When you combine that with the digital signatures aspect, this lets you ensure that both parties hash the data the same way, so that when they compare their signatures, it's easy to validate that they were both sent by the correct party. So if we talk about licensed servers, these servers are really the gatekeepers. They authorize playback once a user has permission, but also they're the same set of servers or API endpoints that will oftentimes register the content for playback. Originally, you had Widevine, which used a centralized licensed server model, but later they moved to a self-hosting model. So that allowed service providers to host their own Widevine license servers. This shift was made to provide more flexibility, additional scalability, and control to content providers. These servers are commonly hosted on, cloud platforms like AWS or Azure for scalability, or Oracle Cloud. Similarly, you've got Fairplay or PlayReady. So these licensed servers manage the decryption process and ensure that only authorized users can access the content. Fairplay, which is used by Apple, integrates tightly with its ecosystem, while PlayReady, developed by Microsoft, supports Windows-based environments, as well as a lot of other devices like set-top boxes and things like that. In addition to the self-hosted solutions, You've also got external service offerings from third-party DRM vendors that provide managed licensed server solutions. These services can often help you simplify the setup and the maintenance process for content providers by offering, a scalable infrastructure and actually reducing the burden of managing all those different licensed servers operations. And then finally, watermarking. It's an essential part of actually securing your video content. And there are various fingerprinting techniques which you can use to track and protect content. There's two main types of watermarking that you'll hear about, visible as well as forensic. Forensic watermarks are invisible, but can be unique to each user if you want. And they help trace back leaks by embedding a unique identifier within the content. These are more like digital fingerprints, and they survive editing and compression. There's a lot more to dig into here. So I just wanted to mention it because it is important to know that, for a secure delivery of DRM, you probably do need watermarking, but let's continue to just the specifics of DRM. So that wraps up your content preparation, and we can take a look through on the final step now, playback. DRM isn't just about encrypting your content. Just remember, it also has to be playable, right? We don't want to make this a situation. A really famous one is the Sony PlayStation. So when the PlayStation released on the market, everybody was excited to use it with their TV, and they had bought a movie. They hooked their PlayStation up to their television. They put a movie in because, hey, the PlayStation has a DVD drive, unlike the Xbox. And then it tells you, hey, by the way, you're not allowed to play this. And everybody's like, what the heck? I bought the PlayStation, I own the TV, I bought the movie, right? That's not the experience that you want users to have. So make sure that, when you're deploying DRM, that you're doing it in a way where the users who are paying you don't get a degraded experience compared to those who are pirating your content. Whether it's, on a TV, a laptop, a mobile phone, there's a bunch of unique APIs to help integrate these DRM systems now to make sure that you don't have another PlayStation incident. For example, on Android, you'll want to use the Media DRM API, which works with DRM systems like Widevine, which is very Google specific. Now, mind you, Widevine you can use on a lot of other devices if they've bring and have integrated Widevine onto them, but they'll all have their own APIs. On iOS and tvOS, you'll use the Fairplay streaming APIs, specifically listed here, the AV content key session and AV asset resource loader for the older APIs. They'll help you manage DRM protected content and integrate with Fairplay to ensure your secure playback. And finally, on the web, you'll use encrypted media extensions or EME. And it provides you kind of a standard way to interact with different DRM systems across browsers. If you imagine every device speaking its own language, these APIs will help everyone understand the message and provide seamless playback. Now, device implementation of those common APIs can sometimes be inconsistent, which often leads to challenges for developers. On platforms where the implementation isn't fully complete, a lack of adequate logging can really further complicate debugging. Therefore, making sure that your implementation has detailed and verbose debugging logs in place is crucial to being able to effectively troubleshoot and address any issues that come up in production. An example of this case, we were dealing with a Samsung mobile phone, and in the UK, we were seeing an issue where we actually had DRM sessions failing to initialize, which was causing the device to go into a fallback path and load lower resolution content. We didn't immediately understand why that was happening. And it ended up being the fact that you had two different chipsets. So in the US, the same Samsung phone was using a different CPU than they were in the UK. So making sure that we had all the logging there in place is what allowed us to diagnose that fact and see like, oh, actually the number of DRM sessions supported on each one of these devices is different, despite the fact that they shared the same model year and name of device. So finally, the last mile, the important piece of playback security, HTCP, high bandwidth digital content protection. HTCP ensures that when a device like your Sony PlayStation or a Blu-ray player sends content to a display, that connection will be encrypted and protected, and it prevents unauthorized recording or interception. HTCP is used in many consumer electronics, including the set-top boxes and the streaming devices, and they help you create a secure link between the content source and the display device. The purpose of HTCP is to deter piracy by encrypting the data as it travels across that cable, like HDMI. So from your actual device to the display device, ensuring that the content remains protected end to end. If we didn't have HDCP, it'd be much easier for someone to intercept and copy high definition content, rendering the rest of the chain up to that point essentially non-existent. This brings up an important point, though, in our understanding of DRM. HDCP v1 has been, defeated or broken. The reason for that is that the master key for HDCP version 1's encryption is considered in the wild. Effectively, it got leaked. And so Intel now has to defend it through legal means and will essentially sue anybody who produces a hardware module who doesn't enforce HDCP correctly. In addition to the HDCP master key leaking, Widevine itself has been defeated multiple times, both through full keybox leaks or other interesting side channel attacks. And finally, PlayReady has also recently had issues due to some symbols leaking. And if you Google, you can find this is related to a thing called Warbird. So despite all the best efforts of the industry, DRM is fundamentally flawed as a determined attacker because they're called what's called white box cryptographic methods. So a determined attacker will always be able to recover that software. With that, we've kind of covered the journey from content preparation to playback, and DRM is used so that that digital content is securely prepared, safely delivered, and accessible to those who have permission. One thing I do want to mention about the prior comment is the reason why watermarking is so important is it allows you to kind of detect that cohort of individuals who may be using one of those techniques to get access to your content and essentially proactively shut them off from being able to have access. So DRM still gives you that level of access control. So let's dive into a few of the implementation specifics. So in the HLS stream, below here we have what's called the EXTX key. That tag, whose payload is below, indicates a key format. That key format is essentially which protection system this data is targeting. The initialization vector, which is the first 16 bytes that will be used to like initialize that encryption, as well is indicated here. And the URI, which has a specific format depending on the vendor that you're working with. Then you have a base 64 component there at the end, which in this case is what's called the PSSH box. This is something that would generally be embedded into your media, but in HLS they pull it up and out, and that's the same actually with Dash as well. Then that content will be given to what's called the content decryption module, or the CDM, and you'll get a payload that you can send to a license server to request the content or the license for that content. If you look here in this case, for this specific one, the vendor ID was an identifier for the application requesting this content, and the content ID was an identifier for the specific content This will be unique per vendor, so that data will change. Now, this here is that base 64 payload essentially decoded. Here it's representing a wideband PSSH box. So here you can see that we've got the protection scheme indicated by the what's called a 4CC, which is essentially the four characters. Now, mind you, it's represented as an integer in this case. And then the key ID, which is again going to represent, remember, if we go all the way back to the beginning, the unique crypto period. So essentially that period of time that this key will encrypt. Now, where that matters is essentially, let's say you're doing a live stream and you're constantly producing content, right? You can't ever shut that stream down. You may want to essentially rotate that key. And so you might rotate the key every hour. And then that way, if someone spends all that effort and they get your key and they figure out what it is through one of these side channel attacks, they're only getting an hour of content. You're essentially limiting the blast radius of what they get access to for their efforts. Now, how does our player, though, get the decryption key? This goes back to where we were talking about EME, the AV content key session, and media DRM. This PSSH box will essentially be given to those APIs, and they'll generate a license request. And then that request will be sent out to the license server that you're using, whether it's by DRM or Ditto, a self-hosted one that you have, or if you're using, let's say, a Speaky gateway with AWS. That network request is actually undefined. So that'll be custom code that somebody like REDspace or whoever else writes for your player. Now, in a lot of the cases, you can very easily define that in the different APIs for the different players because it's such a common thing to have to do. And then finally, there'll be like a little transformation API that will convert that server response, which, because it can be different, back into what the CDM wants. So, and then finally, like I mentioned before, the key rotation. Here in this case, if you're using MP4 and you have what's called a constant IV, which is essentially you're going to use the same initialization vector for every segment and rely on the fact that because you're not going to send the same media, you'll be able to differentiate the encryption key, even though you have the start with the same 16 bytes. So you're not making it too easy for an attacker effectively. That will let them, you need to really do the key rotation pretty much. Otherwise, after, let's say, about a day, it'd be really easy because essentially, if you have a day that's like 3,600, minutes. Sorry. Anyway, I'm not going to do math, but effectively, if you have enough segments, it becomes really easy to essentially figure out what that original 16 bytes was that you were using as an encryption key. So you want to make sure that you're doing key rotation. And in the case of VOD, any of these providers, they're going to use a different key per piece of content. So you don't have to worry about it in the case of VOD. And with that, I just want to say, thank you for listening. And to help aid any questions, I'm going to leave a diagram up here that kind of shows the full architecture flow. Thank you very much.
Perfect. Thanks for that, Jamie.
Yeah, no problem.
All right, you covered a lot. So we do have some questions coming in. So I'm going to do my best to get through them. We don't have a ton, but we have a little time. So if you do have any questions out there and you want to ask them, please put them in the Q&A tray in the bottom. So really in no particular order, one that came in, and I found this one interesting as well. What do you think is the hardest part of implementing DRM in a real world situation? Like, what is something that we should be keeping in mind just as a possible gotcha? Or if you were starting your journey today, make sure you answer these couple of questions.
Yeah, it's really about like setting up what devices you want to hit. So if you're a business and you're looking at like, hey, I have this content, and I want to make sure that it's accessible by everybody on modern browsers. That's really easy. And if you start to get into some of the older set-top boxes, the decisions around those encryption modes that you're going to use changes. And the reason why is because the spec was not like, okay, it is 2014 and everything's perfect and nothing's changed. Device implementations vary. The
Sure.
spec has changed multiple times through that time period. And so effectively, you need to use the counter mode encryption on some of those older devices. And you need to use like an older 8-bit play ready version. And why this matters essentially is that it starts to add up in actual business cost
I
because
bet.
you've got to have now either two copies of the encryption of the content encrypted, or you have to do what's called just-in-time encryption. So just-in-time encryption is where at the very last moment, right when a user is going to request the content, you encrypt it and you give it to them.
Yeah.
Um, and that's really like it all becomes a balance of managing cost to the number of users that you're going to be able to get. So if you think like, hey, we're going to get 10 million people on Roku, it's really worth it to add Roku. If you're going to get, maybe 100,000 people on a Samsung 2017, it's probably worth it. But if you were like, actually, I only think we're going to get like 5,000 people, it may not be worth it for you to add a whole new class of content to target that device class. So yeah, knowing that like what content types you need to target which devices and kind of
Mhm.
what you're looking to target as far as where you can play your content back.
That's
That's
great.
that's
Now,
really
again, I'm going to riff here a little bit, and if I'm off base or it's impossible for you to answer, or you're not comfortable answering, I'll give you the out there. But is there like a recommended best practice for the amount of coverage? I know if it comes down to it all comes down to dollars and cents, but like if you were launching a new product today, what sort of market coverage or device coverage would you be looking for as a recommendation?
It would depend on whether or not it was advertising based or subscription based revenue is what I would be looking at.
Oh,
Because if it's subscription based, you're going to have a much better idea probably if you're already in market of like
hmm,
what your incoming revenue is. If it's advertising based, as many eyeballs as you can get, right?
there you
Um,
go.
so that's kind of like I would say it's a lot easier if you're advertising is get on as many devices as you can. It's probably worth it.
Oh, that's good advice. I'll take that as a good answer. So next question is, um, and again, probably a personal preference question, but you have way more experience than me on this, so I'll ask it anyway. Uh,
Mhm.
how do you decide which DRM to use? Like, if you were going to give advice
Oh,
to a relatively new, someone new in our audience, or someone who is considering either migrating their DRM or considering it for the first time, what would you recommend?
yeah. So this is definitely where it would be depends on your contracts with the content owners.
Sure.
That would be one reason why it would depend on which DRMs you would use. They
Hmm.
might mandate particular levels. So that's actually one thing I didn't mention. In the different DRMs, you have what's called a hardware DRM or software DRM. And that kind of is the level of where is that DRM implemented. And the movie studios generally require what's called L1 in Widevine or software level in PlayReady. And the really that's what drives it is effectively what are they going to require if you're not the content owner, if you're getting someone else's content, what do they want you to use? And
Right.
then if that's not a necessity, it's really again what devices you're going after. You can get a huge amount of devices with just Widevine. Um, of the two that I was going to add, it would probably be Widevine and PlayReady if I was targeting like a 10-foot device, because then I'm only losing iOS and Apple TV, but I'm hitting every other device on the market. So
And
yeah,
for those
that's
who
really,
don't know, what's the 10-foot radius, just for clarification?
oh, sorry, 10-foot devices. That's like
10 feet.
your living room devices. So if
Got
you're
it.
looking at like set-top boxes, televisions, smart TVs, um, you're trying to just like sit on a couch and watch television. If you're doing that, those are the two different DRM systems I would target.
Perfect. All right, we've got a couple more that have come in. I'm going to. I cannot filter whether or not this is right or wrong. So, both of them are somewhat related. One is how does key rotation strategy differ between live versus a video on demand, considering late joiners, DVR windows, etc.
Oh, okay. Um, so I've personally never implemented key rotation for VOD content. That's
Okay.
not to say that you couldn't do it, but I haven't done it before. The reason why is because if you're doing key rotation for live content, you're doing it because you're producing the content for a long period of time. And
Mm-hmm.
so there's a lot of content. If you didn't do key rotation, that content would all be encrypted with the same key. And then if that key was defeated, you'd get all the content. Now, in the case of VOD, if you change your key per piece of content, you're encrypting a much smaller amount of content with that key.
Got it.
As well, it's in the case of VOD, it's kind of you start the process, you do the encryption, and you're done. In the case of the live, it's kind of, ongoing. And so you need to have a way to, during the process of doing the encryption, change that key out. Um, so the most important part, I guess I would say, is like I haven't done it for VOD and for live doing the actual key rotation. Um, you can end up what's called with a thundering herd. So essentially,
Phantominous.
yeah, it is. It's effectively, let's say you have a few million users who are all watching the same content,
Mm-hmm.
and at exactly 60 minutes on the hour, you change the DRM key. Now, every user who was watching is going to hit your DRM service at the exact same time. And so now you have 2 million people, like clockwork, going to hit you. Uh, So it's important. There's some techniques where you can essentially have that slightly shifted so that you spread that load out, um, basing the key rotation on like essentially a duration of retry period of like 5 minutes on either side. So you can kind of spread those requests out and not actually bring your own servers down.
I was going to say that feels like the voice of experience talking.
Yeah, less so on the DRM side and more on the like authentication and
Sure.
authorization side. Um, it's a big problem if you, let's say, you have every single user needs to validate the fact that they paid. That's
Yeah.
definitely one where if it's like, hey, if you only do that the moment that the event goes live, you've got to make sure that you've got enough server capacity to handle the number of people that are going to hit you immediately on the event going live.
So what do you call that? Thunderous what?
Thundering herd.
Thundering herd. All right, good
Yeah,
to know. That's a new term for me today.
yeah, yeah.
We did have another question, and again, this is interesting for a few reasons. For me, not the least of which is around professional sports. So they got a massive issue with piracy, and as you see DRM evolving, as some of these professional sports organizations and live streaming partners make effort to include in-stream betting capabilities. What do you see happening there? I know, again, I will caveat this by saying this is not legal advice. Um, One man's opinion, who happens to have lots of experience. That question came in from an anonymous attendee who who may or may not have some interest in sports betting and live events. So
Right. Um, I would say like so the most important part honestly is not DRM actually. It's about making sure that you don't have cheaters. Um, so if you think about live betting, uh, and you're doing a stream, and let's say we're using a technology like HLS or Dash, your latencies are going to be like 6 to 12 seconds on average, unless you're doing low latencies. If you've got someone who can push their stream to the front of the latency tail, they now know 6 seconds ahead of everybody else what's going on. So that's a big problem if you're doing like live betting. And so the whole
cool.
industry is actually just working on making sure bringing everybody as close to that latency edge as possible. as well as like attesting to when the bet was made on the client side.
Okay.
Those are the two things. I honestly wouldn't think that DRM is only going to be as important as what the content provider is requiring you to. That would be if I was looking at a live betting solution, I'd want to make sure it's kind of like closed circuit horse racing. Like if you look at history, horse racing actually used like closed circuits. So everybody was shown the horse race at the exact same time when they were doing betting.
Hmm.
It's the same problem, but now you're doing it over the internet. So you need to make sure that like you have a global clock and you're showing people the live stream at the same time.
Yeah. There are no new problems. Yep,
Yeah.
everything that's old is new again. That is terrific. I hope we answered your question, anonymous attendee. But I thought that was terrific, and perhaps I'm going to use that as a bit of a segue to get into, this is intended to be the first in a series of webinars that we do. We will be looking for input from others around what other topics. Feels like we may have just uncovered, maybe not the next one, because we do have a webinar coming up in the next 2 to 3 weeks around quality engineering. So look for an announcement from that from REDspace on our LinkedIn page. We'll have Jonathan Terry joining us for a similar type of environment. We're looking at probably about 30 to 40 minutes, a little bit of time left over for questions at the end. Before I wrap up and let everyone go, Jamie, anything else you want to add for the folks here? A little last minute words of wisdom, whether it's related to DRM or any of the other things. I know you have a ton of experience, and one of the things at the risk of sounding like a blatant sales pitch, if you do want to just have a conversation around any of these things, happy to talk to someone. So, Jamie, I'll give you the last word, and then we'll sign off.
Yeah, no, I would just say is that like if you're planning on rolling out DRM, make sure that you keep the customers happy because the first thing is that the moment somebody hits that use case where they get DRM blocks them from watching something they should be able to, that's when you start to turn people away from paying for your content to not. So yeah, it's as important just to make sure that you keep everything working than actually having DRM secure the content.
Perfect. Can't think of a better way to end. All right, everyone. Thanks very much for attending. Jamie, thanks for your words of wisdom. And with that, gang, we'll sign off and we'll see you next time.